This video is for section 2-4, Equivalent Inequalities. Let's discuss the addition property of order. In this statement, A, B, and C are real numbers. If A is less than B, then A plus C is less than B plus C. And if A is greater than B, then A plus C is greater than B plus C. This is saying if you have an inequality with a less than symbol or an inequality with a greater than symbol, you can add the same number to both sides of that statement and you still get a true statement. Let's solve this open sentence. Add 5 to both sides. We get x is less than or equal to 15. Any number that's less than or equal to 15 is a solution to this inequality statement. Next, let's discuss the multiplication property of order. Again, A, B, and C are any real numbers. If A is less than B, then A times C is less than B times C if C is greater than 0. But A times C is greater than B times C if C is less than 0. The symbols C is greater than 0 means that C is positive. The symbols C is less than 0 mean that C is negative. Hopefully you recall this from Algebra 1 class. When you multiply both sides of an inequality by a positive number, you have the same arrow symbol as you did in the original inequality. But if you multiply both sides by a negative number, then the arrow symbol switches direction compared to the original inequality. Let's work an example. Negative 2 times x is greater than or equal to 8. To get x alone, we divide by the coefficient negative 2. Because we're dividing by a negative number, we have to switch the order of the inequality symbol. And over here we have negative 4. In the next example, we scribble out this equal symbol and replace it with a less than arrow because we want to practice inequalities, not equations in this section. To get the n alone, we would divide both sides by 16. N is less than negative 3. We have the same inequality symbol as the original inequality because we did not multiply or divide by a negative number. We divided by positive 16. The subtraction property of order says you can subtract the same number to both sides of an inequality and you will get a true statement. The division property of order works the same way as the multiplication property. If you divide by a positive number, keep the inequality symbol the same. If you divide by a negative number, switch the direction of that inequality symbol. Any of these transformations create equivalent inequalities. And just like with solving equations, we create a sequence of equivalent inequalities until we have the variable alone. Here's an example. Solve this inequality, then graph its solution set on the number line. First, let's subtract v from both sides. 3v subtract v is 2v. On this side, there's only a negative 1 left. Next, subtract 5 from both sides. Now we have 2v is greater than or equal to negative 6. Next, divide by 2. We have v is greater than or equal to negative 3. At no point did we ever multiply or divide by a negative number, so our inequality symbol has stayed the same all along the way. There is a closed dot at negative 3 because of the or equal to, and then we shade to the right. All the numbers greater than negative 3. Next example, solve the inequality and graph the solution set. First, let's do the distributive property. 3 times 3 is 9. 3 times minus k is minus 3k. Next, let's combine like terms. 9 subtract 10 is negative 1. Next, let's add 1. Negative 3k is greater than 3. And next, let's divide by negative 3. Because we divided by a negative, switch the direction of the arrow symbol. 3 divided by negative 3 is negative 1. There's an open circle on negative 1, and then shade to the left. Here are all the numbers less than -1. Let's summarize the lesson. We discussed how to solve inequality open sentences. The process is the same as with equations. If there's anything different at all, it's when you multiply or divide by a negative number, you switch the arrow symbol.